Alright, now we got question number 21. The directions are finding roots of polynomials. So this is a pretty big Algebra 2 concept, college algebra concept. There's a lot we can talk about with this, so I'm going to kind of just give you the basics and what I want you to know for this next year. So basically we have a polynomial, a third degree polynomial, set equal to 0. So what I ask you guys to think about a lot in calculus is think about what the graph of this and some of the behaviors and the properties of this graph shape are before we even start doing any math with it. So hopefully you know a little bit about cubic shape, and they have kind of a that shape, I guess. The end behavior is always going to be in opposite direction, so down up or up down, and in this case the coefficient is positive, so we should know that this graph shape, I'm not even going to write the axes yet. This graph shape does something like this. It has that potential anyway. Alright, roots are also known as roots. They're also known as zeros. They're also known as x-intercepts. They're also related to linear factors. So we've got 4 things we can call the same sort of idea, and they all have their own context, but they're all pretty much related to the same idea. So we've got an idea of what this graph shape looks like, and we want to know where it's equal to 0. So that's basically saying where on the x-axis is it crossing these 3 points. And there's 3 possible zeros because of, we should know that without even looking at or thinking about this graph shape. That's fundamental theorem of algebra. This thing has possibly 3 zeros. So we know we're looking at something like this, and this is the x-axis. So there are concepts in college algebra and algebra 2 that are good, like rational roots theorem, synthetic division. All those things kind of relate to breaking down polynomials. For our class, we're going to accelerate that. We might review this a bit during class time in calculus, but for our class, one thing I want you to realize is the use of a calculator is always an option. So even if you weren't sure what this graph shape looks like, you can always graph it on a graphing calculator and get what it is. So speaking of that, if you were to graph this, you would find very quickly that this is the y-axis, and that one of the zeros is right at the origin, 0, 0. What you could also find are these 2 points right here, these intersection points. I think your command on your calculator is roots or zeros or something like that. But what you'll find is these are not nice numbers. They're decimals that your calculator has up to about 6 decimal places, which is a good indicator that these are irrational numbers. So because the directions called for exact answers, we can't use those decimal approximations. We need to do an exact algebraic approach to this. Well, one thing we already know that a 0 from our calculator, x equals 0, is one of the zeros. Okay, we could have found that without a graphing calculator, because if you look at this polynomial, it has the term x in common on everything on the left-hand side, so we can actually use algebra and factor that out. Change over to a different color here. This thing, algebraically, we can factor out that x, and that leaves us x squared plus 2x minus 21 equals 0. So we're just undistributing that x. If we redistributed it, we get that back out. So this is algebraically sound. So this x right here is directly related to that intercept. That means if we put 0 in for that x, it's going to destroy whatever this stuff is and make that equation true. That's where we're getting x equals 0 as an x-intercept. X equals 0 comes from that right there. Now, the rest of this, and hopefully you were able to see this, is when we factor that out, now we have this relationship right here, which is a quadratic. So if we think about just that portion of it, this is a parabola graph shape. It's related to that, although our original polynomial is a cubic. But what comes up with quadratics is a variety of methods of solving. Sometimes we look at factors like if this is a binomial, what 2 numbers multiply to give us negative 21 and add to give us positive 2. Well, there's not a lot of factors of negative 21. 7 and 3 come to mind, But however you kind of mix and match these negative and positive symbols, you're not going to end up with this 2 for any of the factors. So that method doesn't work out. There's some other methods like completing the square, but one thing you're going to want to have access to is the quadratic formula, which is, we already know that these are not nice numbers. If they were nice whole numbers, that method I just erased would have worked out well. It would have gave us some nice whole numbers like 3 and 21, or sorry, 3 and 7. But because we already know we're dealing with ugly numbers, that means a radical is involved somewhere, irrational numbers, so that's a good indicator we want the quadratic formula. So hopefully we all have that memorized, but if not, go look it up, because you should have it. So let me get some space right here. And we are just going to, I guess since I did this in red, we're going to stick with red, and we're just talking about this part of it. So quadratic formula, x equals, so I've got a, b, and c all lined up. X equals negative b plus or minus the square root of b squared minus 4. A is 1, c is negative 21, running out of room, all over 2 times a is 1 again. So that's the quadratic formula. It's a little sloppy over there, but hopefully you can figure that out. I'm going to move over, and now we just simplify this, work underneath the radical. So 2 plus or minus the square root of 2 squared is 4, minus 4, positive 1, and negative 21. These two negatives are going to yield a positive. So let me write that 2 squared is 4 right there. These are going to yield a positive, and 4 times 1 times 21 is 84, all over 2. And let's do one more line of simplification. So we have negative 2 plus or minus the square root of, looks like 88, all over 2. So quadratic formulas kind of yielded this. Now we have this concept of, this is technically a algebraic correct answer, but it's not simplified all the way because of this right here, the square root of 88. So how to deal with that square root of 88, or how to simplify that is, well, 88 is not a nice perfect square. If it was like 81, well, that would be easy to do. So we have to kind of go over here and think about the square root of 88. And I always break this down. It's called prime factorization. So you start breaking it down by things that divide it. So 8 and 11 multiply together give you 88. And when you hit a prime, you circle it. Or I circle it anyway. 4 and 2, 2 is prime. 4 breaks down 2 and 2. So what that means is 88 is the same as 11 times 2 times 2 times 2. It's called the prime factorization. And what that means is because of the square root symbol, pairs get to escape. So I'm going to pick a pair of 2's. They come out, and I'm going to rewrite this answer as negative 2 plus or minus. That pair of 2's get to escape as a 2. And this 2 and that 11 are stuck underneath, and we multiply them back together to give us 22 all over 2. So that's the simplification of that radical symbol. And then we see that these 2's are all in common, so we can cross-simplify, and those all become 1. So our answer from the quadratic formula is negative 1 plus or minus the square root of 22. Now keep in mind, this plus or minus symbol means two answers. Negative 1 plus that quantity, and negative 1 minus that quantity. Okay, so what does all this mean? Find the roots of the polynomials. We found 2 of the roots, and here's in the exact form. This should be the same as the decimals we found with our calculator on the graph. If you were to put this into your calculator, it should come up with the same values as what your intersection points were if you tried it that method. So there's 2 of our roots, 2 of our answers, and the other one, again, we found real early. That's that interceptive x equals 0. So your 3 answers are right there. Now question number 22 is a very similar process. So if you didn't get 21, I want you to try 22 on your own, because it's pretty much the skeleton of how to do that one. It's just going to be some different numbers, but I think it's important to think about graph shape, what we're doing with these quadratic formula, what it means in relation to this problem, so be mindful of that.